questions 11 through 20 on the 2002 grade 12 AMC 12B. The positive integers a, b, a minus b, and a plus b are all prime numbers. The sum of these four primes is. So we have a, we have b, we have a minus b, and we have a plus b. And these are all prime numbers. And then they're saying if you add them all up, like this, a plus b plus a minus b plus a plus b, what is this? Well, this looks like a, 3a, b's cancel, 3a plus b. So we obviously have to assign some numbers to this, otherwise all we have is a's and b's. All right, no problem. First, let's list some of our primes, starting with the lowest prime, which is 2. 2, 3, 5, 7, 11, 13. And let's see if we can get this type of a scenario. So we have 5. 5 is 2 less than 7, and 5 is 2 greater than 3. So I think if we let a equal 5 and b equal 2, this should work. So a minus b becomes 3, and a plus b equals 7. There you go. So that basically means that a, b, a minus b, and a plus b are all prime numbers. And now we have to figure out what is this. Okay, so 3a is 3 times 5 plus b, so this is 17. Now let's look at the answer choices. 17 is even. No. 17 is divisible by 3. No. 17 is divisible by 5. No. 17 is divisible by 7. No. 17 is prime. Indeed it is. So the answer to number 11 is E. The letter E. For how many integers n is n over 20 minus n the square of an integer? So we'll make a little table for ourselves. N over 20 minus n, and let's see what we get. So first thing I notice is that we can't let n equal 20, because if we do, this expression becomes undefined. So 20 undefined. And then similarly, if we have an n greater than 20, like 21, this starts to become negative. And that is not going to work, because we want this expression to become the square of an integer, and the square of an integer is always positive. So we obviously have to look at values less than 20, integer values less than 20. And yeah, and very similarly, we have to make sure that we put in values that are positive, because if I start putting in negative values like -1, again, we're going to have a negative number. -1, if I put that in, it'll make this expression negative. And I can't have that, because I want this expression to be a square of an integer, which is always positive. So our boundaries look like 0 and 19 in terms of the smallest and the largest. Okay, so let's go with this. If n is 0, we get 0 over 20, which is 0. Is that the square of an integer? Yes, because 0 squared is equal to 0. So we've got 1. How about when n is 1? We get 1 over 19. 2, we get 2 over 18. 3, we get 3 over 18. And so on. 4 over, this should be a 17 right there. 4 over 16. 5 is 5 over 15. 6 is 6 over 14. 7 is 7 over 13. 8 is 8 over 12. 9 is 9 over 11. 10 is 10 over 10, which is 1. Is 1 the square of an integer? Yes, it is, because 1 squared is 1. So we've got 2 now. All right, so I ran out of space, but I can scroll down. It's okay. Oh boy, I got to squeeze this in somehow. I'll do it on the side here, no problem. N over 20 minus n. So what are we up to? 11? Yeah, 11 becomes 11 over 9. 12 becomes 12 over 8. 13 is 13 over 7. 14 is 14 over 6. 15 is 15 over 5, and that's 3. Even though that's an integer, 3 is not the square of a number. 16 is 16 over 4. That's 4. Is 4 the square of an integer? Yes, because it's 2 squared. So now we've got a third one. 17, 17 over 3. 18 is 18 over 2, which is 9, and that is 3 squared. So we've got another one. And finally, the last one, 19 is 19 over 1, which is 19, which is not the square of an integer. So we got 1, 2, 3, and there was a fourth one, 4. So 4 values of n make that expression the square of an integer. So 12, the answer is D. The sum of 18 consecutive positive integers is a perfect square. The smallest possible value of the sum is. So we have n plus 1, n plus 2, and there's 18 of them, all the way up to n plus 17. And that is going to be a perfect square, so x squared. So add all this up and we'll have 18n, and then 1 plus 2 plus 3 all the way up to 17. We use that formula, n times 1 over 2, to add up consecutive integers from 1 to n. So that will be 17 times 18 over 2 is equal to x squared. Okay, so now we have 18n plus 17 times 9 is equal to x squared, and therefore 18n plus 153 is equal to x squared. So now this has to be some perfect square. So let's experiment with values of n. When n is 1, we'll get, what will we get? 171. Is that a perfect square? No. If n is 2, we'll get 189. Is that a perfect square? No. How about n equals 3? We'll get 207. That's not a perfect square. When n is 4, we'll get 225. That is a perfect square because 225 is equal to 15 squared. All right? So therefore, this is our value, and that's the lowest one because I was doing it in chronological or chronological. I was doing it in increasing order. So I'm doing that to get the smallest possible sum. So 225 is the smallest possible sum that you can get with 18 consecutive positive integers. That makes the sum a perfect square. So 13, the answer is B. 4 distinct circles are drawn in a plane. What is the maximum number of points where at least 2 of the circles intersect? Okay, so let's draw our circles. That's our first one, and we're going to draw 4 of them, right? Yeah, 4. So here's our second one. So I've got 2 intersection points. We've got a third one, and we've got to draw it in a way to maximize intersection points. All right, so I think that should maximize it because that intersects everything twice. And now I've got the last one. So how do I draw this last one? I got to draw it in a way so that it intersects everything at least twice, and I think that does it. Okay, so now let's count intersection points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 intersection points where at least 2 of the circles intersect. So 14 is D. And there's no way you can get 16 because I've done it in the maximum possible way. How many 4-digit numbers n have the property that the 3-digit number obtained by removing the leftmost digit is 1/9 of n? So you have a number n, and it has 4 digits. 1, 2, 3, 4. And I'll just call them A, B, C, and D. Then what you're doing is you're removing the leftmost digit. So you're removing A. And when you do that, you get left with B, C, and D, like that. And what they are saying is that the result, BCD, right here, BCD, is 1/9 of the original n. So that's A, B, C, D, like that. All right? So they're wanting you to figure out how many such n's can you get. So the way you would approach this is you would have to start putting this in the form of a number. So for example, if you have BCD, that is really 100B plus 10C plus D, correct? In terms of its value. And similarly, this on the other side is 1000A plus 100B plus 10C plus D, like that. All right? So cross multiply and the 9, and you'll get 900B plus 90C plus 9D is equal to 1000A plus 1000B plus 10C plus D. And I think we can get rid of some of these. This one will subtract from that to give 800B. Similarly, we'll get 80C, and 8D is equal to 1000A. All right? And then finally, we can isolate the 8. We can factor out an 8, and that becomes 100B plus 10C plus D, and then we can put the 8 on the other side, like that. And there we go. This is about as far as we can get. We have so many variables here. We have 4 variables. So now what we can do is we can pretty much use inspection starting with values for A. So I will start with the smallest value, A equals 1. When A equals 1, what will this become? Well, when A is 1, we will get 1000 divided by 8, like that. And that is equal to 125. So that basically means that 100B plus 10C plus D is equal to 125. And what was 100B plus 10C plus D? It was this number right here. All right? So that's one possibility. So that means that our n, I'll put n over here. If you remember, n was A, B, C, D, correct? So I'll put n, which is A, B, C, D, and then I'll put the other number, which is B, C, D, like that. So we figured out with A equal to 1 that our B, C, D number is 125. So I'll write that right there, 125. And therefore A, B, C, D is 125, correct? This fulfills our criteria, whereas if you remove that, this is 1/9 of that. All right, so we will continue in this fashion. So next, A equals 2. If A equals 2, that means 100B plus 10C plus D, if you use this equation right there, becomes 2,000 over 8, like that. And 2,000 over 8 is 250. So therefore, our now BCD number is 250, and our ABCD number is 2250. And this number is 1/9 of that number. All right, so let's keep going here. When it's 3, it's 3,000 over 8, which gives you 375. When A is 4, you get 4,000 over 8, which gives you 500. When A is 5, you get 5,000 over 8, which is equal to 625. When A is 6, you get 6,000 over 8, which is 750. When A is 7, you get 7,000 over 8, which is 875. When A is 8, you get 8,000 over 8, which is 1,000. But 1,000 is not a 3-digit number, so that cannot be used. So we've exhausted our possibilities, and we got 8 of them. 1, 2, 3, 4, 5, 6, 7. Sorry, we got 7 of them. 7 ends. So let's figure out what the ends are for each of these. That should be pretty straightforward to do. First, let me list those numbers, the BCD numbers. And then the ends, you're just adding the A's. So let's see, this one was 3375. You don't really need to figure out the ends, but I'm just doing it for the sake of completion. 5625, 6750, and 7875. So we got 1, 2, 3, 4, 5, 6, 7 such ends. So therefore, the answer to number 15 is 7, which is D. Juan rolls a fair, regular octahedral die marked with the numbers 1 through 8. Then Amal rolls a fair 6-sided die. What is the probability that the product of the two rolls is a multiple of 3? So there's a short way and a long way. I'm going to explain it the long way because the short way doesn't explain things very well. So Juan has a die and it's got the following numbers, right? 1, 2, 3, 4, 5, 6, 7, 8. And then Amal has a regular die that has 1, 2, 3, 4, 5, 6 on it. And then when each of them rolls a die, you take the number that Juan gets and the number that Amal gets, and you multiply them, the product, and we want to get that product as a multiple of 3. What is the probability? So the very first thing I'm going to do is figure out what is the number of possibilities. So for Juan, he has 8 possible numbers that he can get when he rolls the die. For Amal, he has 6 possible numbers. So the total is 8 times 6, which is 48. So that is the complete set. Now we have to figure out, of all those 48, how many will be a multiple of 3. All right, so let's start with Juan. He first rolls a 1, right? Let's say. What would Amal's number have to be in order for the product to be a multiple of 3? Well, for 1, it can be 1, 3, or it can be 1, 6. If Juan rolls a 1 and Amal rolls a 3, the product will be 1 times 3, which is 3, which is a multiple of 3. If Juan rolls a 1 and Amal rolls a 6, the product will be 1 times 6, which is 6, which is a multiple of 3. All right? So very, very similarly, I'll do all the other ones. If Juan rolls a 2, how do you get a multiple of 6 as a product? For Amal, he would have to roll a 3. If Juan rolls a 2, Juan can also get a combination with 6 to get a multiple of 3. Similarly, 2 times 3 is 6, which is a multiple of 3. 2 times 6 is 12, which is a multiple of 3. How about if Juan rolls a 3? Well, 3 is a multiple of 3 itself, so anything that Amal rolls will satisfy this condition. Right? So I hope that makes sense. Moving right along, if Juan rolls a 4, Amal would have to roll a 3 or a 6. Okay? If Juan rolls a 5, Juan again would have to roll a 3 or a 6 in order for that product to be a multiple of 3. If Juan rolls a 6, well, 6 is a multiple of 3 itself, so anything that Amal rolls will satisfy the condition. All right? And 7, for Juan, Amal would have to roll a 3 or a 6. And finally, 8, for Juan, you would have to roll a 3 and a 6. Amal would. All right, so let's count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 ways out of the total, which was 48. And that is a half. So I hope that explains it a little bit better than the quick way. The quick way was just, well, we got 2 over 8, and then you take 3 over 4, and then multiply it by 1 over 3, and there you go. That's the answer. And that doesn't explain anything, unless you're absolutely brilliant and you understood that. So number 16 is C. Andy's lawn has twice as much area as Beth's lawn and 3 times as much area as Carlos's lawn. Carlos's lawn mower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. If they all start to mow their lawns at the same time, who will finish first? So we can kind of illustrate this in a way that matches what information they give us in the question stem. So this is Andy, this is Beth, and this is Carlos. Now first let's concentrate on the area of their lawn. They tell you that Andy's lawn is twice as big. So let's just say it's 6 meters squared. And it's twice as big as Beth's lawn, right? So that means Beth would be 3 meters squared. And Andy's lawn is 3 times as big as Carlos. So Carlos's lawn is 2 meters squared. And then they tell you information about the lawnmower in terms of how fast it cuts. Carlos's lawnmower cuts half as fast as Beth's lawnmower. So let's say his lawnmower cuts 2 meters squared per hour. Half as fast. So Beth's is 4 meters squared per hour. And Carlos's lawnmower is 1/3 as fast as Andy's. So this would be 6 meters squared per hour. And now we have to figure out the time for each of these. So for Andy, 6 meters squared divided by 6 meters squared per hour, that would give you 1 hour in terms of his time. Very similarly for Beth, 3 meters squared over 4 meters squared per hour, and that would give you 3 over 4 hours. And Carlos would be 2 meters squared over 2 meters squared per hour, and that would give you 1 hour. So they're asking who finishes first. Well, the person with the shortest time would finish first, and that would be Beth, because she does it in about 45 minutes. So therefore, number 17, the answer is B. A point P is randomly selected from the rectangular region with the vertices 0, 0, 2, 0, 2, 1, and 0, 1. What is the probability that P is closer to the origin than it is to point 3, 1? All right, so we will draw a diagram. So here you go. We've got this XY plane. And let's start labeling our points. 0, 0 is here. 2, 0 approximately here. And then what do we got? 2, 1, so about here. 2, 1. And 0, 1, so right here. 0, 1. And this is obviously a rectangle. We'll draw that, connect the dots like this. And they're saying that they want you to assign a point somewhere in here. So let's say here, P. And the point P is closer to the origin than it is to point 3, 1. So where's 3, 1? 3, 1 will be approximately here. This is 3, 1. So if we connect the dots again, let's say the origin is here. So P to the origin is there, like that. And P to the point 3, 1 is like that. They're saying, what is the probability that P is closer to the origin than it is to point 3, 1? All right, let's label point 3, 1 as Q. So they basically are saying, find the probability that OP, which is the distance from P to O, the origin, is less than PQ. What is the probability that P is closer to the origin than it is to 0.31? Okay? So I hope you understand that. The basic premise of the question, what it is that they're asking. All right, so P has the coordinates x, y. And since P is inside this rectangle, x and y have boundaries, right? X has to be less than or equal to 2, that 2 right there. It has to be greater than or equal to 0. And y has to be less than or equal to 1 and greater than or equal to 0. Okay, so those are the boundaries of P. P boundaries. All right, so let's go with exactly what they're asking for. They want OP less than PQ. So how do you figure out the distance between 2 points? X minus 0, remember this is 0, 0, it's the origin, squared plus y minus 0 squared, all under the square root sign. That's basically the distance of OP. Now the distance of PQ, 3 minus x squared plus 1 minus y squared, all under the square root sign. We can square both sides, get rid of the square root signs, and this just becomes x squared plus y squared is less than 3 minus x squared plus 1 minus y squared, like that. All right, let's move this up. And now we can expand. So what do we have? 9 minus 6x plus x squared plus 1 minus 2y plus y squared. And looks like the x squared and y squareds disappear, which is good news for us. So that leaves minus 6x minus 2y plus 10. And then I'm going to isolate for y here. So we've got 2y is less than 10 minus 6x. Divide through by 2 and we get y is less than 5 minus 3x. Y is less than 5 minus 3x. So this is our condition. Now, these are our boundaries, correct? So y is less than 5 minus 3x. I'm going to write that up over here. Y is less than 5 minus 3x. So what exactly does that mean? We got this nice equality, but what does it mean? It means this is a line, and y is less than that line. So let's plot that line. And when I plot that line, I'm sure it will make sense to you. I'm going to plot this line, y is equal to 5 minus 3x, and then show that y must be less than that. So to plot a line, you just need 2 points, right? So let's just find the x and y coordinates. When x is 0, y will be 5. And when y is 0, x will be 5 over 3. All right. So, oh boy, I gotta put a 5 on this graph. All right, I think I can do that. Bring it down a bit. So here's our 5, and I've got to draw a line that connects those two intercepts, and I drew that red line. So that red line basically represents y is equal to 5 minus 3x. And now this is when our inequality, or equality, whatever you want to call it, comes in. Y is less than that. So it is this region right here, less than that. Okay? That is the region that this is defined by. Because we have to stay within our boundaries. That's why I only highlighted the area within that rectangle. So that's it. To figure out the probability, we just have to figure out the area of that shaded region and divide by the total area of that rectangle that is drawn in orange. Okay, that shouldn't be too hard. The first thing, of course, I'll need is one point that will allow me to draw a triangle, and I'll show you what I mean. Let me draw a perpendicular from this point to this point right here, from this point down to here. If I can find this point right here, I'll be able to figure this out. That point. Well, that point basically is when y is 1. When y is 1, what is x on this line? Well, when y is 1, we have 1 is equal to 5 minus 3x. And therefore 3x is equal to 5 minus 1, which is 4, and therefore x is equal to 4 over 3. So that is 4 over 3. And if I can now split this up, I will be able to figure out the area. So the area will be calculated as follows. First, I'll figure out the area of this rectangle, correct? And then I'll add to it the area of this triangle, and that will give me the region that I am interested in. And then I'll divide by the total, which is basically the total rectangle. Okay? So that shouldn't be too hard. So let's do it on the side here, so I can keep that graph in vision. All right, so here we go. Area of this square, or rectangle I should say, this guy right here, is length times base. Length looks like 4 over 3, and the height is 1. And then I have to add to that this triangle right here, this guy. So that is 1/2 base times height. 1/2 base is 5/3 minus 4/3. I got to find that distance. So that's 1/3. So 1/3 is the base, and then the height is just 1. And then now I have to divide, because I remember I'm trying to find a probability, by the area of the entire rectangle. So the entire rectangle is just length times width, which is 2 times 1. And there you have it. So this looks like 4 over 3. This looks like 1 over 6 over 2. So this looks like 8 over 6 plus 1 over 6 over 2. 8 over, oops, sorry, not 8. 9 over 6, all over 2. So 9 over 6, invert and multiply, 1 over 2. And we got 9 over 12, which is, of course, 3 over 4. So there you go. That's our probability. 3 over 4. And that would mean that number 18, the answer is C. If A, B, and C are positive real numbers such that A times B plus C is 152, B times C plus A is 162, and C times A plus B is 170, then A times B times C is. So first, let's work with what they gave us. We have that is equal to 152. B times C plus A is equal to 162. And C times A plus B is equal to 170. Expand, I guess. AB plus AC is equal to 152. BC plus AB is equal to 162. And AC plus BC is equal to 170. Correct? And now where would you like to go from here? A lot of possibilities, a lot of variations of how to solve this. I'm just going to add them all. So add up everything. So we have AB plus, if I can write it properly, AB plus AC plus BC plus AB plus AC plus BC is going to be 152 plus 162 plus 170. And let's see, do we get anything here? We got two ABs, okay, two ACs, and two BCs. And I think I forgot to put the C there. So, okay, so at least we get something. And then this total is 484. Factor out a 2, I'll divide through by 2, and you'll get AB plus AC plus BC, and then 484 divided by 2 is 242. All right, where do we go from here? Well, this right here that we just got looks very similar to all of those up there. In fact, it looks identical with the exception of one term. So I'm going to call this 1, I'm going to call this guy 2, and I'll call this guy 3. And I'll call this 4. If you take 4 and subtract from it 1, you'll be able to solve for at least one of those terms. So for example, 4 minus 1, you have AB plus AC plus BC, correct? If you subtract from it 1, you're subtracting AB and AC. And then, of course, you've got to do the same for the other sides, 242 minus 152. But watch, the AB's disappear and the AC's disappear. So we just get BC is equal to 242 minus 152, which is 90. All right, so I think that is the direction we're going to go in. That's going to help us. Very similarly, I'll subtract from 4 now 2. So again, we got AB plus AC plus BC minus 2, which was BC minus AB. And then the number part becomes 242 minus 162 this time. So the ABs go, and I think I forgot the BC again. BCs go, so now that we're just left with AC is equal to 242 minus 162, which is 80. And one last time, 4 minus 3 would give you AB plus AC plus BC minus AC minus BC, and then the number part would be 242 minus 170. And in this one, ACs go, BCs go, and we're just left with AB is equal to 72. All right, this is going to help us figure this out. Remember, what do we want to figure out? A times B times C, right? Well, we've got BC is equal to 90, AC is equal to 80, and AB is equal to 72. So multiply them all. BC times AC times AB gives you 90 times 80 times 72. And watch what happens. You get A squared, B squared, and C squared is equal to some big long number, right? 90 times 80 times 72. Now if you take the square root of both sides, you will get ABC. And that is what they want you to figure out. So the square root of this number, this big long number, is 720. So there you have it. With a little bit of fancy manipulation, we got down to what we wanted. So ABC is 720, and therefore 19. The answer is D. Let X, O, Y be a right angle triangle with measure of angle XOY equal to 90. Let M and N be the midpoints of legs OX and OY respectively. Given that XN is 19 and YM is 22, find XY. So here's our diagram here. We've got a right triangle, something like this. Okay, and then let's label it. We've got X, O, and Y, and this angle XOY is 90. And then they draw these midpoints, I guess, M and N, the midpoints of OX and OY. So the midpoint approximately here, like that, and the midpoint of OY approximately there. So those are represented by the letters M and N. And what do they want? They want you to figure out XY. So they want you to figure out the length of that guy right there. And they give you some numbers though. We can label them. They tell you that XN is 19. So X to N is 19. And YM is 22. So YM is 22. Y to M, that line. Okay, so where would you like to progress or proceed, I should say. All right, so N is the midpoint, right? This guy is the midpoint of OY. So that means it cuts OY in half. So we can label this B and B. And very similarly, M is the midpoint of OX. So M cuts OX in half. So call this A and that A. All right? And then we immediately, or at least I hope you can see Pythagorean relationships. There's one here with this triangle. And then there's another Pythagorean relationship with that triangle right there. So let's write those two relationships out. So the first one, we get 2a squared plus b squared is equal to 19 squared. And the second one is a squared plus 2b squared is equal to 22 squared. And I think, yeah, that's pretty much the foundation. And then we can manipulate those and eventually figure out xy. So this becomes 4a squared plus b squared is equal to 19 squared. And this one is a squared plus 4b squared is equal to 22 squared. And then I'll just add them. So that'll give me 5a squared plus 5b squared is 19 squared plus 22 squared, like that. So 5, factor out the 5. 19 squared is 361 and 22 squared is 484. So this becomes 845. 5a squared plus b squared. And then divide through by 5. And that will give you 169. Okay. Now let's turn our attention to xy. Xy we can figure out again with Pythagoras, but this time it involves the entire triangle. So it will be 2a squared plus 2b squared is equal to xy squared. So let's move this up. So this becomes 4a squared plus 4b squared is equal to xy squared. Factor out the 4 and you get a squared plus b squared is equal to xy squared. And a squared plus b squared we got right there, 169 is equal to xy squared, like that. Correct? 4 times 169 is 676 is xy squared, and therefore xy is the square root of 676, which is 26. Correct? So therefore we found xy. And that means the answer to number 20 is B.